is to talk about duration neutral portfolios, okay? As I explained in class, duration neutral portfolios are essential when you don't know what will happen with interest rates. So you don't want to take a bet on interest rates, okay? And hence you want to create portfolios which are immune to interest rates going up or down. So these are duration neutral portfolios, okay? Those are portfolios where the duration equals to 0 and the convexity of the portfolio is positive. The classical example of that I gave you in class, right, is let's say that you have $50 million in a zero coupon bond. Okay, so this is a market value. This is not the principal that you pay then. This is a market value in zero coupon bonds that matures in 30 years. Okay, now let's assume that you have a 5-year zero coupon bond and you want to create a duration neutral portfolio. So how much you want to invest in a 5-year zero coupon bond so that the overall portfolio duration would be 0, right? So if you want to solve it, you want to first assume that your market value of the 30-year zero coupon bond equals to $1. So you invest $1 in a 30-year zero coupon bond. You want to understand how much you need to invest in a 5-year zero coupon bond to kill the duration of a 30-year zero coupon bond. So the overall portfolio weight must be 1, okay? And the portfolio will always have a cash component. So now you have basically the following, and you can assume, okay, at least initially, the WI, the W30 equals 1. Okay, so now you want to calculate the equation for duration. So you have the following position. You have a 30-year zero coupon bond. You have a 5-year zero coupon bond. Okay, and you may have some cash. Now, cash doesn't matter because the duration of the cash is 0. So you want to concentrate on these two, okay? And hence, you have the following equation. You have 1 times 30, and then plus 5 times W1, W2, let's say, W5, right? Which equals 0. So you want to actually, you are asking yourself, okay, how much I need to invest, right, in order for me to kill the duration of the portfolio. And you use the formula WIDI. Okay, now the W30 is D30 is 30, right? And D5 is 5. So that's why this formula is true. Now you are going to solve for W5, and you're going to get that this is going to be minus 30 divided by 5, right? Which is minus 6. So conclusion is that if you want to actually create, if you have a $1 in 30 years zero coupon bond, you want to invest in minus $6, right, in a 5-year zero coupon bond to kill the duration. Okay, so then you will also have a $6 cash component. Why is that? Because when you actually borrow, how do you actually create a minus 6, right? So you need to borrow the 5-year zero coupon bond. Okay, and now you want to sell it on the open market because otherwise your balance sheet is going to look like that. It's going to be 30-year zero coupon bond minus 5-year zero coupon bond because you borrowed. But before you sell, you will have plus 5-year zero coupon bond, right? So you see that the zero coupon bonds are killing each other, right? Because you actually hold your 5-year zero coupon bond in your balance sheet, it kills your short. So you want to actually, to create a genuine short, you want to sell this 5-year zero coupon bond for cash. And that's where this cash component here, after you sell, this cash component here is coming from. So what is going to be the duration of this portfolio? So we already saw that this is 5, 1, 130 minus 5 times 6 plus 0 times 6, because this is cash, equals 0. What is going to be the convexity? The convexity is going to be as follows. This is going to be 900. Now, the convexity of a 5-year zero coupon bond is maturity square. So it's 25 times 6 plus 0 times 6, which is going to be 750. Okay? So convexity, you see that the convexity is 750. Now, let's assume, okay, that the yield goes up by 1%. Okay? So if the yield goes up by 1%, what is going to be the performance of this portfolio? So it's going to be minus duration of the portfolio times the change in yield plus half of the convexity of the portfolio times the change in yield square. Okay? The yield goes up by 1%, so it's going to be 0 minus 0 times 1% plus half times 750 times 0.01 square, which is going to be, right, 0.0, I think, 375 or something like that. Okay? So, you know, what will happen here, okay, that your portfolio is going to actually make money when interest rates are actually going up, right? So this is a little unusual. I wouldn't say that, you know, because if you have a positive duration portfolio, you will not have this kind of phenomenon, okay? So, okay, you will not make almost 3% or 4%, right, on a 1% move up, if you are going to have such a, you know, if you are going to have a positive duration portfolio, right? Because we know that, let's say if we have a 5-year duration, then this is going to be probably your performance minus 5%, right? So this is highly unusual. Now, if it goes down by 1%, right, you will get the same thing. It's going to be minus 0 times minus 1% plus half times 750 times minus 0.01 square, right? So this is going to be, once again, 0.375. So you went down here, you went up here, you still make money. So that's why those portfolios are very attractive to portfolio managers, because you can actually make money in an environment when interest rates going up or going down, and you don't need to worry about the direction of interest rates like you do in usual portfolios. Okay, so hopefully this was helpful to you, and good luck in the test.